Hello everyone. So we all have heard about the non-inverting amplifier as a case of voltage feedback, and we have calculated the open loop gain and the feedback factor and related it to the classic feedback model. But can we do it for the inverting amplifier? So for the inverting amplifier, we have something like this. Let's say this is R1, this is R2, this is the input, and this is ground. So what we have in here is the gain is minus R1 over R2. So the feedback factor should be minus R2 over R1. And the loop gain, if you find out, it will be equal for the both of them, for inverting as well as non-inverting. It will be R2 by R1 plus R2 times A. But the thing is, the A here will not be equal to the gain of the op-amp, and we'll see how. So we break the loop, but now we do not know what do we do for this node, because this will be a floating node. So if you see the four models of feedback and see how do we handle loading, you will get to know that we would ground this node, and a plausible explanation for this would be because the looking in impedance here is 0, so we ground this node. And now if you circle for the loop gain will be, let's say you start from here or anywhere for that matter, the loop gain will be A0 times it will be R2 over R1 plus R2. Okay, for calculating the loop gain, you can start at any point and you will find out that the loop gain equals this. So this will be the open loop gain for the op-amp will be this, because when you have the input here, let's say the input here is V, then the input here will be, this will be R1, V times R1 over R1 plus R2, because this node is ground, and this will be multiplied by the open loop gain of the op-amp to give this. So the value of the A, which is the forward gain here, will be different from A0, and it will be this because of the voltage division that happens between R1 and R2 to give the potential of V R1 by R1 plus R2 at this node, because this node is ground. Now if we wish to calculate the value of A beta, that will come out to be A times beta, and A is A0 into R1 by R1 plus R2, and beta will be minus R2 over R1. And this, as I mentioned, will be equal to the overall loop gain, which will be same for the non-inverting case, because the non-inverting amplifier as well as the inverting amplifier are the same when you ground the input. So for the non-inverting amplifier, you have the input here and this is ground, but when we calculate the value of A beta, we null all the voltage sources, so you will null this, so it will make no difference whether the amplifier is inverting or non-inverting with respect to the loop gain A beta. So A beta will be the same for both the cases, because it will not matter where the input is, because anyways both these nodes are going to be grounded. So if you calculate the loop gain will come out to be A0 times it will be R2 over R1 by R1 plus R2. This will be the value of A beta. Now if you find the value of beta from here, you will see that this equation is satisfied even if you make beta as an unknown. You will find out the value of beta as this will be negative, because we have a negative terminal here, so it will be negative. So you will find out the value of beta as minus R2 over R1, giving the value of the gain as minus R1 over R2. So this is how you can fit the voltage model to an inverting amplifier, The only piece of information is the A is not A naught, it is this because of the voltage division that happens from input to this node, and that this node is ground because of the 4 topology feedback effect of auto handle loading, and a plausible explanation as I previously mentioned because the looking impedance here is 0. Thank you for watching.